All right. Okay, welcome to United Astronomy Clubs of New Jersey. So, because I see some stragglers coming down and find their seat, uh, once again, thank you for joining us for our last presentation of the 2023 season here at the Observatory in Jenny Jump State Park in Hope, New Jersey. Uh, this presentation it is usually the most festive. We do enjoy having a little bit of fun and dressing up for the upcoming Halloween holiday. So I want to, since we do live stream this, and yes, we do live stream on YouTube and Twitch, so do hit those like and follow buttons when you go home, or if you're joining us online, do hit those now. You can also check us out on our website, uacnj.org. That's where you're going to find a list of all our upcoming talks because even though we're not here at the observatory during the winter, we do still keep giving talks, just we move to an online only format. You can also check us out on our social media pages. So we got Facebook, Instagram. We have our Discord channel. Feel free to pop in those questions and space photos. I always like to see them. And you can also, because we are a nonprofit, you can also find ways on our website to help us out and briefing. If you need to use the bathroom, that is the porta potty in the back to my left, your right. It is illuminated by red, and the Grim Reaper here has joined me to point you in the right direction. We also have a gift shop and museum area that I'll be manning after the talk. It's the doorway to my left, illuminated by red. We have a lovely museum display of meteorites and various other telescopes and fun things. Do check that out. Now, if things smile down upon us, perhaps during the presentation, the clouds might clear, and hopefully we'll be able to show you things through a telescope. Uh, if that happens, each of those sheds that you passed when you were parking and walking down actually houses its own telescope, and the roof rolls off, and hopefully we'll be able to show you something in the sky besides just clouds, as has been the norm. With that, tonight's presentation is space weather in the cold Antarctica, but with Gil Jeffer. Gil retired in 2006 after a 20-year career as a senior scientist with Mars Incorporated. When the New Jersey Institute of Technology approached UACNJ about locating their 48-inch telescope at Jenny Jump, Gill immediately got involved with the project. He now works for the Center for Solar Terrestrial Research at NJIT, where his positions include research engineer, data communications engineer, and he is the director of the NJIT Observatory in progress here at Jenny Jump. In 2012, he was invited to join NJIT Antarctic team and now has made 8 trips, totaling more than half a year on the ice. His work in Antarctica is funded through grants from the National Science Foundation, and Gil's here to tell us all about that.
It's all glad you're here tonight. Pleasure seeing you. First, off, we see the pre things here as far as what you been up there for a while. You can look at that, see what you have to do. But with the clouds tonight, it might not be too good for viewing, but we never know. It could happen. So I'll talk a little bit about space weather in Antarctica, and what space weather is how I'll start. And then I'll switch over to a little bit about what it is, well, a lot of it actually, about what it's like to go down there, what it takes, what travel down there is like, and what working down there is like. It's kind of a unique place to work. First off, what is space weather? Space weather is basically just the physics of the sun-Earth environment, the interaction between the two. Move this away a little bit. UACNJ, which has been the one that drives this for me, has gotten involved in quite a few projects. These are just a few of them. Some of them are in California, some in Peru, others in New Jersey, some right here, and others in Antarctica. Everything from solar observing, space weather, to atmospheric research, to ionospheric research, quite a bit. So a little bit technical here, but what is space weather all about? Space weather is basically The sun emits radiation. It flows towards the Earth. The Earth has a magnetic field. It interacts with the radiation that's coming from the sun and coronal mass ejections, and that's what causes space weather on Earth and the upper atmosphere. So first off, you have electromagnetic radiation all the time coming from the sun. It takes about 8.5 minutes for light and any other radiation to reach the Earth. It's very short. So when you're looking at the sun, you're actually looking back in time for 8.5 minutes. But there's things that happen on the sun that aren't just like a light bulb. You have solar flares and other coronal mass ejections. When that happens, basically, it throws a lot of energy towards the Earth. Coronal mass ejections can be billions of tons of energy flow, or billions of tons of mass is ejected from the sun and come towards the Earth. Solar flares eject radiation to the Earth and it interacts with our magnetic field with the upper layers of the atmosphere. A much more complicated picture, but this shows you something. Basically, at the poles, which is one of the reasons we do things at the poles, is where, let's see if I have a cursor here. Yeah, oh, damn it. Ignore that. You can see the dotted lines coming into the Earth. That's what happens where the cusp is, where the magnetic radiation and ions can come in towards the Earth and interact with the Earth's magnetic field and interact actually with our atmosphere. The whole, you see that globe around the Earth that's pushed out towards the back, that goes back millions of miles. But what that is basically the sun is pushing that magnetic field of the Earth and making it more into a teardrop shape instead of a round shape like you'd expect from a magnet. You look at the Earth's magnetic field, it is pretty much like a magnet. There's a north and a south pole, which we're all familiar with. But it does get messy when the sun hits it. It's not quite like a bar magnet anymore. That's why it's pushed off to the side. But it's pretty much like that. The Earth's poles actually flip. They flip every 200 to 300,000 years, and they're actually overdue for flipping. When they flip, it takes quite a long time, decades before they turn around. But the sun does the same thing. The sun's magnetic field also flips, but it does it approximately every year, and that's the solar cycle. And the sun's always in a rapid state of flux. The Earth's magnetic field is pretty steady, except for when solar events impinge on it. But the sun's magnetic field is much messier. Basically, this is just a snapshot of a model of what the sun's magnetic field looked at a point in time. It's always changing. It changes by the minute. The solar activity of sunspots, they're caused by disturbances in the magnetic field on the sun welling up through the surface of the sun. Solar flares are caused by tangling and crossing of magnetic field lines near sunspots. And coronal mass ejections, where I was talking about billions of tons of material ejecting from the sun, can accompany flares. And when that happens, when the solar flares, the magnetic coronal mass ejections happen, if they happen to be aiming towards the Earth, they can cause disturbances on the Earth, quite a bit of disturbance. So this is a little bit of a model of what happens here. You can see the hot rising gas coming up from the sun. Where you have a sunspot, they're cooler. They're still about 6,500 degrees, so you don't think of that as cooler, but on the sun it is. And that's where the magnetic field loops can come out of the sun. Sometimes these break, sometimes they basically snap, and that's where we get the solar flares. And occasionally you have solar holes, which we'll get to that in a little bit, but solar holes also. And that's where a lot of material can flow out of the sun towards the Earth, or towards any direction, actually. So the solar cycle I mentioned was about 11 years. It actually varies between maybe 7 and 14. Typically it's 7 years though, or 11 years though. The last solar cycle was very low. It was the lowest we've had in maybe 100 years. You can see right here on the right hand side, you can see that low bar. The one we're having now was predicted to be as low as last cycle, cycle 24. But 25 is starting to surprise people. It's actually ramping up. It was supposed to peak about July of 2025, but just 2 days ago they moved that up, and now they say this coming January through October, somewhere around there in 2024, it should peak. And just Thursday they updated the intensity of it. It was supposed to be low like last year, but now it's closer to an average solar cycle. What are the coronal mass ejections, the solar flares, magnetic radiation storms, geomagnetic storms affect? Quite a bit. actually quite surprising. Astronaut safety, actually, even when you go over the poles in an airplane, you typically pick up about 2 chest x-rays worth of radiation. But if there's big solar storm is happening and an astronaut was doing an extra walk outside of this space station, it could actually be very dangerous for them. We also have currents in the ionosphere, atmospheric drag on satellites, which can slow down the satellites. When they slow down the satellites, they drop to a lower orbit, which means they have to use fuel to boost them back up to their normal orbit. It also can cause a lot of damage with surface charging to satellites to the instrumentation. So one of the ideas of predicting this and actually monitoring this is so they can put their instruments into a safe mode where they won't get damaged. On Earth, radio wave disturbance. Radio wave disturbance can affect high frequency radio transmissions. It can also affect GPS transmissions, so that you can easily, if you have a severe solar storm, it can actually block GPS. But otherwise, the accuracy can be affected. I mentioned airline passengers. Also, water vapor in the air. It can actually cause changes in our weather, interference in radar. Electrical grid disruption is a really big one, what it can do. Also, telecommunication cable disruption. Basically, what happens is a generator basically is a moving magnet over wire. And any kind of long cable, long electric transmission grid can also, when these fields move along them, can generate current. One of the most unusual ones is lower left there, the pipelines. Pipelines are made out of metal. The material that welds them is a little bit different kind of metal, and when these storms happen, they can cause hundreds of amps of currents to throw through them and cause corrosion slowly, not all at once, but corrosion along these welds. So what they typically do is they put a bucking current when they detect that back to go the other way to neutralize it. So talk about 1989. You think about solar radiation and what it can do to us. In 1989, we had actually a pretty big one. I don't know how many young ones were alive then, but in 1989, it took down the electrical grid basically in Quebec pretty much for about 12 hours, and also in part in the northeastern United States. A coronal mass ejection, where those billions of tons of particles aimed towards Earth hit, coupled with the electric fields and coupled with the transmission wires, blew out some transformers, shut down others. It was a 12-hour blackout in Quebec. New England Power had problems, New York had problems, and 96 electrical utilities were interrupted. So there are 200 power grid problems reported in the USA. These storms can happen at any time, but they typically happen towards when a solar maximum is happening. Communication satellites were also disrupted. Shortwave communication backouts, and they actually lose control of the satellite because the communication is bad, so they can't adjust the attitude. So the track of the satellite and the orientation of the satellite gets affected. It's very important that you can control the orientation of the satellite because their antennas have to be pointed at Earth to communicate with them. So GOES weather satellite communications was completely lost. And they saw aurora as far south as Texas and Florida, which is kind of special. But that wasn't the biggest one ever. The biggest one ever that was recorded in our time was the Carrington event in 1859. That was pretty fantastic. Really great, actually. It would be nice if one of them happened now for space weather research, but actually be terrible for us on Earth. At that time, the only big electrical systems out there were telegraph for railroad for the most part. But what happened was when this storm happened, the telegraph operators actually had things happen where they had sparks coming out of their equipment. They could disconnect the batteries and still use them. They were actually being powered by the sun, if you want to think of it that way. And it caused terrible disruption with the telegraph operations. If that happened today, it would be absolutely horrendously bad. Because now we don't just have telegraphs, we have everything else for our electrical grid, radio communications. It would typically could blow out many things that are plugged into an electrical outlet if it was that big. This actually started fires at a few of the stations, and a couple of the operators got some pretty bad shocks out of it. We actually had a very near miss in 2012. In 2012 was a storm that was comparable but not as close to the Carrington event. Luckily, as I mentioned, they can be aimed any way. It wasn't aimed directly at Earth. So you can think of these things as basically a beach ball where the storm can come out of any side of it. If it happens to be aiming towards Earth, that's when we have problems, or that's when we have aurora. If it's not aimed at Earth, we're lucky. But that one could have been very closely, and they actually estimated the economic impact could have been $2 trillion from that had that hit Earth. And in 9 days earlier, it would have hit Earth. The sun rotates just like the Earth does, but the sun rotates a little bit different. It rotates on average of 28 days for one revolution, and the equator rotates 2 weeks faster than the poles. In other words, it kind of twists. Doesn't rotate as a unit like the Earth does. But 9 days earlier, that would have been aiming right at the Earth, and that on the lower left and on the right are the storms. What would it look like with when it erupted. Jeez, I'm having problems here. So the fun part is aurora. Aurora is what I love to see, and I've only seen them twice in my life. I've seen them in New Jersey, which is kind of amazing. I've never seen them in Antarctica because I'm down there in the summer. In the summer, it's 24 hours a day of light, so I never see the aurora down there. But what happens when the aurora is when these energetic particles come in the cusp and energize just like they would a fluorescent lamp. Fluorescent lamps work very much like an aurora does. In a fluorescent lamp, you have mercury vapor, and you have an electrical current coming through it that ionizes it, and it glows. In an aurora, you have different colors from the different elements that are ionized. You have oxygen, nitrogen, other molecule or other atoms that are energized, and that causes that glow that you see in the aurora of the different colors. This is an aurora that was taken time-lapse at the South Pole in Antarctica. Absolutely gorgeous. You can also see the Milky Way behind it, and you can see it's time-lapse. The sky is moving overhead. Recently, we've had some events here, which not too long ago, whoops, gotta watch my hands here. Not too long ago, just this May, just a couple months ago, we had a few basically pretty strong storms. One of them basically caused radio blackouts over Northern America and Southern America. And also you can see on the lower left, this is from that storm where it ejected that explosion. It looks like an explosion coming out from the sun. That disk in the middle is to block off the brightness of the sun. They put that when they take the image of it. And you can see how much it came out from there. That was in May, and things can change very quickly. Right now, there's only a few sunspots available. Just a couple days ago, there were 2. Right now, there are 5. Things can change pretty quickly, but that quick one disrupted radio communications and made GPS a little bit less accurate and sometimes unavailable. What's happening right now is there's a coronal hole. What a coronal holes typically come when there's not many sunspots on the sun, like there isn't now. When there's a lot of sunspots, it typically tends to push those holes closed. But those coronal holes can can open up, and what happens is now the wind comes towards the Earth at a couple of million miles an hour. This one's actually going 1.1 million miles an hour, and it is headed directly towards Earth. As a result, on the 30th, 2 days from now, it should hit Earth, and we may have some aurora, but only at high latitude, so probably up in Canada. Unfortunately, not down here, because I love seeing them. When can you see them down here? Well, you have to have a pretty strong storm to see them in New Jersey. And there's basically a map here that you can see, and the yellow line is where there's an index called KP. It's K planetary, that's what the P is for. And you see New Jersey is between 7 and 9. KP runs from 0 to 9. When KP is about 7.5 or 8, that's when you have a really good chance of seeing aurora down here. If you want to see if there's a chance, you take a look at spaceweather.com. These pictures are from earlier today that I took, and you can see the aurora is way up north. But like I mentioned, on the 30th, it should be down lower toward the lower part of Canada. And right now, KP was running at 4.33, and I mentioned it has to be about 7.5 or 8 for us to see aurora down here. When it gets this low, you can typically see it, but if you can't see it and it looks close to it, if you take a time lapse with the camera, a lot of times you'll get it because this camera is integrating light over time. So you'll be able to see it in your pictures, even though you can't see it with your naked eye. Can you see aurora in New Jersey? Yeah, you can. Actually, this was taken in 2023 in Montague. And KP at that point was pretty strong. It was 8 plus. And by the way, typically during a solar cycle, typically during a solar cycle, you'll be able to have almost 100 times where that KP will be up high enough to have a solar storm. Typically, you never know. Here's another one that was done in Cape May County, pretty far south of New Jersey, and that was from the same event. Notice it's not quite as nice as it was in Antarctica, but still it's quite a spectacular view. First time I saw one was here in 1996. A friend that lives down here in Vienna called me up and said, "What's going on in the sky?" And at that time we had a landline. I put the phone on the table, walked outside, and completely forgot about her and just watched the aurora until it faded away. Went back in, saw the phone on the table, called, "Pat, I'm really sorry, I forgot." Felt very embarrassed about that. So now that was just a little bit about space weather. Now I'm gonna switch gears. And what we're gonna talk about a little bit is going to Antarctica, what it's like to work down there, some of the trials and tribulations of working down there, the beauty of working down there, and why is space weather done down in Antarctica as opposed to here? Why Antarctica? Well, there's a whole bunch of reasons for it things that you can do down there that you can't do up here. The first thing is the cusp where the solar wind comes into the Earth's atmosphere is there. It's nowhere else on Earth, just North Pole and South Pole. North Pole is basically on ice. There's not a continent underfoot. You cannot put a man stationary and keep it stationary. At South Pole, you can. The cusp can be studied continuously. Well, you do have satellites that go over polar orbits instead of just around the equator. But even then, they typically go around the Earth in 90 minutes, and at most you'll get maybe 10 minutes before it's out of view. At the pole, you can study it continuously. You don't have those breaks of 80 minutes, 10 minutes, 80 minutes, 10 minutes. In the winter, you have 24 hours of continuous dark. So for aurora viewing and astronomy, the same patch of sky remains overhead. Here, basically, you see the sky moving. That's why we have the different constellations going overhead. At the South Pole, they twist, they turn on moisture, and you have that large area of landmass, so you can take readings from all over the place and integrate them together to see not only what the intensities are, but how they're moving over the Earth's surface. Most people don't think much of Antarctica. It kind of looks like a coffee stain on the bottom of a map, and most maps don't show much of it. But it is really huge. It's about 1.5 times the size of the United States. And that's when there's not sea ice around. When there's sea ice around, it's much bigger than that. This next slide is quite a few facts about Antarctica, but just slapped together all at once. It's a very cold place. It averages at the South Pole, the average year-round temperature is 57 below zero. It's covered in ice. 99.7% of the continent is ice, and it averages 1.2 miles thick, 3 miles in places. It's dry. In the interior of Antarctica, it's basically considered a desert. It's windy. The high sustained wind, mind you, we're not talking about a storm, a sustained wind, 218 miles an hour. And at Vostok, the Russian station, their average wind speed is 50 miles an hour. When we have 50 miles an hour here, basically we have limbs breaking off of trees and all sorts of things happening down there. That doesn't happen there because there's no trees, so it's good. It's also very high. It's the highest continent. Average height is 6,500 feet. The South Pole is at 9,100 foot elevation. And what's interesting about that is 9,000 feet of that is ice. There's only 300 foot of continent. And it's very lonely. There's not many people down there. You have between 1,000 and 5,000 people scattered across the whole continent. Remember, it's 1.5 times the size of the United States in the summer. In the winter, much, much fewer. And some of the places I work, as few as 3 people. Sometimes we have 4. How do you get there? This is basically what I mean as far as doing research down there is very fantastic for what you can do, but getting there and working there is a bit of a trial and tribulation. So we typically fly from Newark to Dallas or somewhere on the West Coast, and then down to Auckland, New Zealand, and then a puddle jumper over to Christchurch, New Zealand. That's all done with commercial flights. Right now we use United Airlines. We were using American Airlines before. We used American Airlines. We went to Sydney, Australia, and then backtracked. It was about 1,000 miles out of the way. I never really figured out why we did that. Once you do that, then you go another 2,300 miles to McMurdo. That's done by the Air Force typically, either ours or New Zealand's. These are the stations in Antarctica that I visit. The yellow ones are manned station. On the bottom there is McMurdo. Sort of towards the top or the middle is South Pole Station. And then far to the right is not a U.S. station. That's Concordia Station. That's a French-Italian station. And we go there too as a drop-off, as a waypoint to get to AGO 5. The AGO, the Automatic Geophysical Observatories, are the blue dots that I showed, that you can see on the map. And those basically are where we have our instrumentation. Plus we have it at South Pole and McMurdo. You can see on the lower right, very lower right, you see the magnetic South Pole. The magnetic South Pole is not where the geographic South Pole is. The geographic South Pole stays in the same place. The magnetic South Pole actually wanders. It was very close to McMurdo in the mid-1800s. It has now wandered actually out into the ocean. First thing you do when we get to Christchurch in New Zealand is we have to get fitted up for clothing because you're going to kind of an extreme environment. So flight requirements, you must get all this clothing and you must wear it on the flight. You have basically a good jacket that's good to about 60 below for a medium amount of time. Balaclava, gloves, boots. The boots are very important. Your feet will get very cold. The boots have very thick soles on them, so they tend to keep your feet quite warm. And you have to wear these on a plane. You don't have to wear the gloves or the balaclava on a plane, but everything else you must be wearing. And you have to show that you have them, and there's a reason for that. The plane flying there, you're now flying on an Air Force or an Air National Guard plane, and it is crowded typically. If you have a C-130, you can see here when people here complain about being in economy seating and only getting 17 inches of arm space in the seat. There, a lot of times you actually have to interlock your legs to fit there. So you're just sitting there, and it's on a C-130, it's about an 8.5-hour flight, and you're sitting like this. So it's pretty arduous to go. If you have a C-17, you have a lot more room, but that's on a C-130. It can be pretty bad. Getting to the bathroom from that, we actually, if you can see that, the seats on the upper right there, you can see where the bar across the top is. One of the crew members actually had to climb along that bar to get to the bathroom because it couldn't get through the people. What's funny is here we have a lot of things with TSA, right, where they're always checking, do you have nail files, do you have anything sharp, knitting needles, pocket knives, whatever else. At going to McMurdo, you have the same type of thing. They also have their checking to make sure you have no sharp things. But the really funny thing is once you get on a plane, there's hatchets mounted on the wall. So I don't really get why you couldn't have a nail file if you can have a hatchet. You can also see, in our commercial flights, you basically have an emergency door. Are you qualified to open this door? There, it's basically you can chop your way out here. So a little bit different. Flying there is always a hit or miss deal. Nothing happens in Antarctica on a clock except the galley. Meals happen on time at South Pole. Meals happen on time at McMurdo. Nothing else happens on time, and even that includes getting down there. It's a long flight, and the plane can make it there, but it can't make it there and back on one shot without getting fuel at Antarctica. So if the weather starts turning bad during the flight, they have to do a U-turn. In 2020, the longest flight we went on was 5.5 hours out, turned around 5.5 hours back. So 11 hours on that plane, and ended up where we started. And on that time, we'd had 5 tries to get out there, 3 actual flights. 2 times we didn't even get off the ground. We were told that we were actually 10 minutes away from the point of no return, which they now call the point of safe return because I guess it sounds better. At the point of no return, you basically do not have enough fuel to fly all the way back to Christchurch. So that's really a critical point to decide whether you have to turn around. So if they're past that point, they have to go to Antarctica. They do not have enough fuel to go back, and no matter what the conditions are, they have to land there. Flying there, once you fly there, you fly over the Transantarctic Mountains getting to McMurdo. They're absolutely beautiful. They're gorgeous. That's where the mountains in Antarctica poke up above the snowpack and above the ice. And they divide the east and west part of Antarctica. And the mountain range is about 2,300 miles long. And it is just gorgeous. You don't have much of a view out of those plains. There's little portals. They're about 10 inches in diameter. But I always try to manage to get to one with my camera if I can. Here you can start seeing some of the glaciers moving along through the valleys there. When we land at Willie Field. There's different airports there, if you want to call them airports. All the airports are on the ocean. There are none on land. So we're actually landing on 24 feet of compacted snow that sits on 8 to 10 feet of ice that sits over 1,000 feet of water. Here's the different airports you can see. One of them was closed down, but Willie Field is the one towards the right. We call Williams Field, we call it Willie Field. And then Phoenix Field is the brand new one. Pegasus Field is closed. Pegasus Field is why you have to, well, not why. Pegasus Field is where we used to land, but there's a place called Black Island down the lower left, and you can see kind of that black smudge. Black Island is so windy that basically it blows all the snow off of it, but it also blows all the volcanic dust over the sea ice. That black on that absorbs the sunlight. The sunlight starts melting the snow, making it mushy even though it's kind of cold. And that's why they closed that, because it was very undependable. A while back, they had a Constellation, which is a tri-tail plane that flew down to Pegasus Field. I'm trying to remember the date, can't remember the date of it. Anyhow, they went past the point of no return. The weather turned bad. They were committed. They had to go to Antarctica. When they went to land, apparently they did a perfect landing, but there was a 6-foot snowdrift. They hit, broke off a wing. That's the plane there. That's the Phoenix, actually. That's what they named the airport after. That's the plane. It's still there. You can actually go into it if you want to. They have tours out to it. And that's the reason you have to have the emergency cold weather clothing on a plane. Back then, a couple of the people on a plane did not have their clothing. They were counting on getting it at McMurdo. Due to the bad weather, it was condition 2. It took about 2 hours to get out to the plane, and at that point, since the plane was not running, it got very cold, and they were close to hypothermia. So that's why you had to wear those clothes all the time. Once you get off the plane, you start seeing there's some really strange vehicles down in Antarctica. This is Ivan the Terrabus. Ivan the Terrabus is one of the vehicles that you use to get from the airport out on the ocean back to McMurdo, back to land. It's a monstrous 6-wheel drive, 67,000-pound creation that does not go fast at all. When you get to McMurdo, it's kind of a first impression is kind of a rundown city built on dirt. It's not dirt. It's actually volcanic, crushed volcanic rock. McMurdo is basically on a volcanic island. All the surface is crushed lava. In the background, you can see Observatory Hill. It's one of the hills that typically you walk up when you first get there. The city is not really nice. It used to be an Navy base in 1959. It is now undergoing a renovation, but they ran into a lot of problems because of COVID. They're 3 years behind schedule. Unfortunately, they knocked down some of the dorms to build the new ones just before it hit, and now the new ones aren't built, so it's a real struggle to get space to stay there. But if you go up on Ob Hill, you'll see one of the crosses from the cross from 1913, that Scott's pole expedition, the one that he failed and died on. The crew that was left in McMurdo put that on top of Ob Hill, and they put that there and would go up there and wait for the expedition to get back from Pole, which they never did. You can also see out in the background, that's one of the airports. That's Willie Field out in the background out on the sea ice. If you look closely. That cross has been there for over 110 years. If you look down at the McMurdo from there, you can see what the kind of area is like. Remember, there's no Home Depot down there. There's no picking up the phone and calling something. There's no Amazon to get parts from. Everything that you need has to be there. And McMurdo is the logistics and hub for all of the United States stations in Antarctica, which include the South Pole and Palmer. Um, so you have to have everything from welders to diesel mechanics to all the fuel to everything. Everything comes in there, and everything leaves from McMurdo. Eventually leaves from McMurdo. You can see the tanks on the right-hand side. They keep 17 million gallons of jet fuel there, called APA. And jet fuel runs a lot of things. Jet fuel is actually running a lot of the generators and everything else too, instead of having all different kinds of equipment there, or all different kinds of fuel. And you can see the little, in the background, you can kind of see the area where the ships come in. It's frozen in this picture. First thing when you get there, you go through orientation and training. You go through the same orientation and training every year, no matter how many times you've been there, but it's good, I guess, because you keeps you up on top of things and you remember, you don't forget things. First thing I noticed was the weather is a little bit different than what we have here. The normal acceptable weather is called condition 3. Condition 2 is when it gets quite cold. Wind chill can be minus 75 to minus 100 degrees Fahrenheit. Condition 1 is when things are really bad. That's when you have real high winds, really cold, and the visibility is really low. At that point, you're not supposed to go outside if you can help it. The first year down there, went through Happy Camper training. Happy Camper is basically, since I work out in the middle of nowhere, not at the stations, you have to get set up with tents, with making your own food and everything else. And we basically, what they do is they group a bunch of people together from different projects and send you out on the ice to learn how to camp in Antarctica. So what they do is, you can see McMurdo Station on the lower left, upper right is where we camped. They take you out there with a snowmobile and all your tents and everything else and all these people that you don't know, and then they leave and they drop you off for the night. At that night, basically you set up your camp and you're basically to see if you can get everything working, all your stuff working, all your camp set up. In the background was Mount Erebus. Mount Erebus is the southernmost active volcano in the world. Actually really beautiful. You can see the smoke coming out of the top of it. It's also the one of 3 volcanoes in the world that has a lava pool in it. So setting up things, basically set up the tents, dig out snow blocks, and once we dig out snow blocks, we make a snow wall. Most of the winds in Antarctica are katabatic, which means basically they come from the cold air falling down from high elevations to low elevations. Similar to when you open your refrigerator in the summer and you feel on your feet, you feel the cold air because the cold pours out and goes down low because it's denser. So you try to find out where the higher elevation is. You build a snow wall there, the snow wall to keep that wind from blowing your tents to pieces, which could be life-threatening. We actually went a little bit overboard because it was absolutely beautiful weather and just kept cutting snow blocks and making a wall that was just absolutely huge. I decided to make a fort underground to sleep in rather than go into a tent because what the heck, why not? It was kind of fun, although I was really surprised when people walk on the snow, even if they're like 50 feet away, it's very loud under there. You just hear that crunch, 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 crunch all the time. So I heard that all night long as people were wandering around. But I'd do it again in a heartbeat. Then we had to prepare ourselves for high altitude work at high altitude. All our stations are at high altitude. McMurdo's obviously at sea level, right by the ocean, but all our other ones go from anyhow from 6,500 feet up to 11,300 feet, or 11,600 feet, I think it is, the highest ones. So one of the things we do is a gamma bag. If you have altitude sickness, it can be really threatening. So the gamma bag is basically like a hot dog. They put you in, and then they pump you up with that air pump to get the pressure up in it to hopefully get rid of your high altitude sickness. One of the people I was with is one standing there with his arms crossed that was pumping up the bag, getting a real kick out of it because that was my first year down there. And I was amazed. My ears popped like you wouldn't believe, and I thought, okay, well, at least that's over with. And then they unzippered the bag, and holy smokes, my ears really blew out. You have to go through quite a arduous physical examination before you go down there to make sure you're not going to get you don't have anything major wrong with you, and you're not hopefully going to get too sick while you're down there. But there is a hospital. This is the hospital at McMurdo. It doesn't look like much, but it actually is pretty well stocked inside. There's a nice pharmacy inside. They also have a dentist chair. They don't have a dentist, but they have a dentist chair. Actually, a funny story though, the nurse I was talking to, and she said one day somebody had a really bad abscess and had to have a tooth pulled down there, and was sitting in the dentist chair just shaking like a leaf. And the man walked in, and he said to him, he said, "I just got to tell you, I'm just deathly afraid of dentists." And being the dry humor down there, he said, "Well, that should be no problem then, because I'm not a dentist." Also, the clock in the galley is a little bit different than what clocks you see here. If you look, all the directions are north all the way around it, which is kind of neat. It's the only place where you can basically walk around the Earth at South Pole. You can walk around the Earth in about 3 seconds. Just walk around the South Pole, and everywhere you go, you're going north. Um, you get used to some of the animals. The only animals that you see are at McMurdo. You'll see these skua. Skua are like very aggressive uh, birds, very extremely aggressive. Think of a seagull, bigger, much more aggressive. They will actually typically hunt in pairs, and they will come after humans if you're carrying food. They will knock food right out of your hand. They'll typically whack you in the head with a wing or hit you with their feet until you drop the food and get it. So typically now what people do is wrap that in saran wrap, so if it falls on the ground, you can pick it up again and laugh at the skua. Other animals that are down there are obviously the penguins. Penguins are only at South Pole, not at North Pole. And polar bears, by the way, aren't at South Pole. They're only at North Pole. But the Adelie penguins are common. They're 18 to 30 inches tall. But the emperor penguins were much bigger than I ever thought they would be. They're up to 4 feet tall, and they can weigh up to 100 pounds. They can dive down well over a quarter mile in the water and can stay submerged for 20 minutes. They trek up to 75 miles to breed. The males actually incubate the eggs out on the sea ice over the winter. So 100 degrees below zero, they just sit there. They don't eat or anything else. They stay there all winter. The other animals you see are seals. Typically we see Weddell seals or other seals down there also. But the Weddell seals are the ones we typically see. They're basically like a fleshy Volkswagen that comes out on the ice once the summer starts breaking up the ice a little bit and you start having cracks in the ice. McMurdo typically puts down a dive tube, which you can go under the ice. You can see in the window here, and actually watch the animals under the water. So this goes down about 15 feet into the through the ice into the water. It's starting to freeze up on the bottom of it, so they're probably ready to pull this out. But you can actually crawl down in this tube and take a look under the ice. There's quite a few divers that work down there. The water's 28 degrees once you're under the ice, and they come up with some really strange animals that they pull out from under there, and that's in a laboratory that you can see. I put one of them in on my hand. It's a sea spider, and really strange looking creature. It's like all legs. But anyhow, back to our work. One of the places in McMurdo is called Arrival Heights. It's up above McMurdo, and it can be very windy there, and also very snowy. Wind down there is such that you have to even anchor down your shipping containers with concrete blocks so they do not blow away. The place I work there is the little hut, basically up there, and it's up there so it's out of the way of McMurdo and all the industry that's going on down there, all the machinery and the cars and the trucks and the generators and everything else. We have instrumentation inside that little building. We work there. All communication is done from a place called Black Island. Black Island is basically the McMurdo ground station. That's how we communicate with McMurdo from here. Actually, we have equipment in here that I get in touch every day with McMurdo and South Pole to pull data from them. That is one of the most extreme places where the weather is. Black Island is the one I showed you where the volcanic rock is blowing out over the sea ice. They get phenomenal winds there. Winds up to 220 miles an hour. Those domes over the antenna are actually made of Kevlar, so they last. And you can see the equivalent of storms they have down there. They have a Category 1 hurricane type storm once a week all year long. They're building a new Earth station at McMurdo. up near Arrival Heights, so they don't have to use Black Island because it's really hard to get to, and obviously the wind is really strong. New York National Guard is the one that take us from McMurdo to South Pole. They use an LC-130. The L on the front means basically it has skis on the bottom, which you can see there. So they can land at South Pole, which is not on sea ice, but actually on compacted snow. It's not quite as good as the snow that we have at Pegasus Field. They're out of Schenectady, New York. You have a lot more room in that plane, even though it's the same plane that we're all crowded in, because not many people go to South Pole compared to the ones that are going to McMurdo at the same time. Again, we go over the Transantarctic Mountains. Again, you can see all the glaciers and the mountains there. You can see here where basically a glacier is starting to form, or the snow pack is basically squishing down through. They don't look very big in this picture, but we're up pretty high. Beardsmore Glacier is 15 miles wide and 200 and some odd miles long. But it's just really wild to go over that and look at it. Yeah, Beardmore Glacier drops about 1.5 miles over the whole distance, and it was one of the early routes to get to the pole back in the early days. And they found fossils there of beetles that were between 14 and 20 million years old on a glacier near that glacier there. Now we're here when we land on pole. They never shut down the plane. The plane propellers are always turning, the engines are always running. They don't want to take a chance of the plane getting cold and the hydraulics getting cold, so it's always running. They just stop. You get off the plane while it's going, walk away, and the plane takes off again. If they have cargo to take off the plane, they do it one of two ways. Either they open basically the access in the back, and they'll come up with loaders and pull the cargo off again while it's running. Or at times they'll actually do a military unload, where basically the plane, if it doesn't have passengers on it, they'll open that back hatch and basically push the stuff out the back, and it just pushes out of the back of the plane as they're going along. South Pole Station itself is really nice. It's really nice. It's like a 5-star hotel compared to what you have at McMurdo. It was built to be lifted up so that you can see there's stilts under it, so that as the snow increases under it, they can actually raise it up. It has not been raised yet. This is a picture that was taken in 2012. Much different now. The snow's up much higher than this now, just in that time. The yellow on top is where basically you go up and make weather observations. You can see there's kind of two halves of the station. In the middle is that white flag. That's a walkway across. It's covered and it's warm. But basically, so if there's a fire, you can isolate one half of the station or the other half. The area there, the immediate vicinity, has a lot of equipment out and back. The storage berms, there's things there that have been there since the early 70s. There's summer camp where if they're doing construction, they have workers that stay out there. A lot of maintenance shops. Again, you need everything from carpenters to electricians to welders to everything else there. And then you see the fuel arches where they are, but they're actually underground. I'll show you pictures of them. You'll also notice a ceremonial pole where you see the 12 flags and a barbershop pole with a globe on top of it. And it's not where the South Pole is anymore. It was there once, but right now the geographic pole is actually even further to the left than where I have it labeled there. The station is on 9,000 feet of ice. It moves about 33 feet a year because the whole thing is sliding on basically an ice sheet. The whole universe out there, you can see you're very isolated. This is a picture from Twin Engine Otter. You can see basically the airport skiway there is 13,000 feet long. A couple of observatories, South Pole Telescope, the Atmospheric Research Station, South Pole, and those other pictures I showed you. That's it. There's nothing anywhere away from you. It's 797 miles to the next permanently manned station, and there's no travel in and out from February until November due to the adverse weather, due to the cold. Buzz Aldrin actually came there when I was there, which was pretty interesting. You can see him here, sitting here, not looking too good. This is kind of funny, for the second man that stepped foot on the moon, he got altitude sickness. So I thought that was kind of hysterical. But he ended up flying out on a plane I came in with. When you look at the weather there, taking a little bit about the extremes, much different than you have here or even in Canada. Basically, mind you, the seasons are opposite of the ones here. So where we're going into winter, they're going into summer right now. We're in fall, they're in spring. But in September early, here's our September 8th. It was 71 below with 102 wind chill. On a really cold day in January 4th, our January 4th, 108 below, 163 below wind chill. So it can get really, really cold there to work. I took a look at the weather earlier today, and it's like I say, it's getting to be spring there, so it's warmed up. It's 61 below with 101 below wind chill. And I went to get the weather forecast, but apparently down there, this is actually hooked up to the station. They stopped doing it. So the last forecast they gave was on May 31st, and now they said survey says no forecast until the end of the winter. They're done, and take it a little bit easy. At the South Pole Station, it'll typically be about 115 people in the summer. In the winter, there's about 40 people. It's much more relaxed atmosphere. Much harder to work there, though. I go in the summer. But you can see that the way you feel about the weather typically is different than what we have here, too. The Antarctic Sun is one of the little papers they put out down there. And you can see the weather briefly turned milder after the storm, with temperatures approaching minus 30 degrees Fahrenheit. So that's a little bit different than we'd be thinking, oh my gosh, I can't believe it's 30 below there. You're looking and going, not too bad. I mentioned a ceremonial pole is different than the actual South Pole. This is a ceremonial pole. The 12 flags were the original signers of the South Pole Treaty, or not South Pole Treaty, the Antarctic Treaty in 1959. But that's not really where the pole is. The South Pole of the Earth doesn't move, but the ice on top of it does. So the marker that you put on top of it has to move to reflect that. So every January 1st, we grab the sign, rip it out of the snow, and move it to where the new pole is. And then you put a marker there, and it stays there to the next January 1st. It's kind of a fun little exercise to do. You can see the snowdrifts can get pretty big there. When you see the two people I was working with walking on the bottom. This structure on the right here is called the beer can. Basically, that's where the South Pole Station merges into the underground areas. You go down a spiral staircase, well, actually a set of staircases to get down there. The door gets you out to the surface, and then you go further down to get underneath it. Underneath it looks like this. There's basically walkways that go to the fuel arches and to the food arches. In the fuel arches, they carry 475,000 gallons of AP8 jet fuel that's stored there. That's to get you through the winter. Fuel comes two ways. It comes either every time a LC-130 comes in, the excess fuel they have, the fuel they don't need to go back to McMurdo, they typically hook up to a pipe and they pump it into these tanks. The traverse is another way to get fuel there. There's also where all the food is stored. Mind yourself, you're below the surface here, so it stays at the average yearly temperature of the South Pole. So these rooms are 57 degrees below zero. So ice cream down there is rock hard, and it can be down there for many years. A lot of the food we had there was from 5-6 years ago, but it's really solidly frozen. I became a hero because when we brought up the ice cream, we bring them up in 5-gallon buckets. They're so cold you typically have to wait about a half a day before you can even get an ice cream scoop in it. And I found you could use a spade bit on a drill and kind of whip it up a little bit and get the ice cream right away. People like that. How do you get water? There's no water down there. It's too cold. There's ice tunnels. There's ice tunnels that run 1,900 feet from the South Pole Station. South Pole Station is up on the upper left. These ice tunnels are where the red lines, and they go to these things called rod wells. Rod wells are holes drilled in the ice that are drilled down and melting. Basically what they do is they pipe hot water down to there to melt the ice, and that hot water now circulates and it's heated. They first start with a hot brass plate, electrically charged brass plate, to make the first one down, and then they take the exhaust heat from the generators that power the station, heat the water, and keep circulating it down there. You can get up to 2,500 gallons of water out of it a day. When they're all done and they have to use it, when it gets too big, basically they start freezing because it's too big of area of water to keep cold. And at that point, they just drain them, and then it's used for sewage. To get down there, this is the entrance to the ice tunnels from that first underground walkway. And you can see it's kind of strange. They're carved out with chainsaws of all things. There's the heated pipe that goes to the rod wells. There's multiple ones. And here you can see the temperature is 57 below Fahrenheit, um, all over down there. There's some strange things down there. People have kind of figured that's a great place to put a few little things like a sturgeon, a pig's head, and kind of a transformer they made out of a power tool. The sturgeon actually has a pretty interesting story. That was actually given to the people at McMurdo by the Russians at Vostok. Nobody knew what to do with it. It sat there until it started to rot. And then they said, let's bring it to the South Pole. They did. And they made this little shrine for it. And that's where it's been sitting ever since. I mentioned Buzz Aldrin got sick there. So now there's a Buzz Aldrin shrine where the tissue used in a cup of water he drank out of. That's down there. I also mentioned that you can't get out of South Pole between February and November, but occasionally there's problems where somebody has to get out because they're deathly sick. They could actually die. In 2016, they had a midwinter medical evacuation. To do that, they take these planes called twin-engine otters, the ones we fly out when we go out into deep field, all the way from Canada, because that's where they're based, and they come down all the way to South Pole. So it was quite a trip down there. They left on June 14th. They got there on June 21st with many stops for fuel. They get about 2.5 miles a gallon. So it took 8 days to get there, to get to Rothera, which is still in Antarctica, which is the kind of just above the Antarctic Circle that you can see in the lower right picture. And basically what they did is then they land. The reason they can use twin-engine otters, they have no hydraulics, so they don't freeze up. Very, very sturdy planes. They're like the John Deere tractor of the skies. They hook heaters up to the engines the second they landed, and they get the people there, got them on a plane, and flew out. That was 2 evacuations were done there. But the most interesting thing was not an evacuation. The one of the doctors at one of the stations, Russian stations, actually got appendicitis. I say one of the doctors. He was the only doctor at the station. So what he ended up doing in 1961, he was the only one doctor with a 12-man crew. He had to take out his own appendix, which I think is just amazing. He started doing it with a mirror and gloves, and being that everything was reversed because it was a mirror, he said it was way too confusing. So he foregoes the mirror, he takes off the gloves, and did it by feel. He did get his own appendix out. He did survive it. And his appendix was black. It was basically almost ready to burst. So he saved his own life. I just can't imagine that. I just cannot imagine that. Taking out your own appendix just to me is as some doctor. I mentioned the 2 ways to get things to the South Pole are by the plane, which you can take just whatever the plane carries, and then the traverse. The traverse is actually done. It's 1,040 miles from McMurdo to the South Pole. They go across the sea ice. They go up the glacier, up to the plateau, and across to the South Pole. And that's actually done with farm equipment, really big farm equipment, all converted to work in the Antarctica. So they have these huge tractors, these huge lights, and plows and everything else, and they go along that 1,040 miles. They carry their own kitchen, they carry their own living quarters, they carry everything they need with them. It typically takes them about a month to get there. You can see the size of that. I'm standing next to one of these tractors. You can see how big they are. They're huge. Interestingly enough, they have what's called a ground penetrating radar running on a huge inner tube, and he runs in front of everybody. Basically what he's doing is looking for crevasses. In certain areas of Antarctica, where I mentioned the ice is always moving, it moves if it's moving over something below that is like a small mountain or hill underneath, they crack, and you get these crevasses that can be hundreds of feet deep. Occasionally, they're closed off on top, so you don't see them from the top. But if any of these heavy pieces of equipment went over them, they would fall in. In fact, people have fallen into them. A couple of years ago, a guy on a snowmobile fell into one and died. When they do find them, they blow them up so that it can be seen. Sometimes they go down into them. I mentioned the South Pole moves 33 feet a year on the ice. Some places they go on a way there move up to 6 feet a day. So although they use a GPS to follow the route, that ice cover on the way there and the ice cover on the way back can be completely different underneath them. So they have to be very careful about the crevasses all the time. But you can see where they just explode them, knock them in. And here you can see a little bit. This is their living quarters. Here's how they bring fuel. On a plane, on a C-130 can typically bring about 3,000 gallons of fuel extra to bring to the South Pole flight. Remember, they want 475,000 gallons. These traverses bring 3,000 gallons per bag, and that's one tractor's worth of fuel right there. So you have 8 bags at 3,000 gallons each, 24,000 gallons. You notice the 2 on the left are kind of shrunk down. That's the fuel they use to get there. They can hit very bad weather where they have huge drifts. And this is when they stopped for overnight. They had a snowstorm, it drifted in, and here they had to plow themselves out. You can also see how hard the snow is from the person standing on top of the fresh snow. He's not sinking in at all. Now on to where I work, the AGOs, the Automatic Geophysical Observatories, which may be decommissioned. These are the blue dots that were on the map. The first thing we do is go to McMurdo to South Pole, the yellow line, and then from there we fly out to AGO 1, 2, 3, and 4 on those twin-engine otters, and then we fly to AGO 5 by going to that Italian-French station, and then out on a twin-engine otter again, or a DC-3 of all things, to AGO 5. Twin-engine otters are the ones that they use for that rescue. They're phenomenal planes. They don't go fast, and they go about 150 knots, 2.5 miles a gallon, but they can really work hard. And they can fly and land in just about any kind of weather and condition. First we get all our equipment that we're going to take out to our remote station, put it on a plane, fly out over this beautiful desolation, which is the Antarctica Plateau. I just absolutely love it. But unfortunately, they don't get great gas mileage, and our stations are up to 600 miles away from the South Pole. So we have to stop and get fuel. They can't carry enough fuel. So we stopped at Roseanne Cash for one of them. That's Roseanne Cash is actually Johnny Cash's daughter. There's also a Johnny Cash and a few other Cashes out there too. At these places, basically what we do is get fuel that's been dropped by an LC-130 or by parachute. They drop these 55-gallon barrels of fuel. We dig them up. We pump them into the plane. We take the empties with us and continue flying to where I work. This is one of them. This is AGO 4. You can see the station on the right. It's 8 by 8 by 16 foot cube, like a little shipping container. And then the other things you see there are a fuel cache, a food cache, and an equipment cache that we have for emergencies. First thing we do when they land is unload the plane with all our equipment. Those are our pilots, by the way. They came into our AGO. We cooked up some hot tea for them before they flew back. First thing we do is dig up some ice and melt it for water, because that's very important for us. There's our instrumentation in the right that we have set up there. We go there. Typically the job I have down there is between McMurdo, South Pole, and at these AGOs is to update, fix, or put in new equipment. We also put in weather stations at different places. University of Wisconsin monitors these weather stations. You can find them online. We reorganize the caches, and then basically once we have everything done and all the equipment done, we say farewell. You can see the plane coming back in for a landing. He'll come in, pick us up, and away we go. This is my last view from AGO 4. You can just see what it's like looking out over the horizon. There's nothing in any direction, nothing whatsoever. There's not a rock, there's not a stick, there's not an animal, there's nothing. It's just ice. It is gorgeous. Sometimes, though, we have to take out something much bigger or much heavier than what they can take out with a twin-engine otter. At that point, a twin-engine otter will fly in a groomer, which is a person with or a couple people with a snowmobile, and that machine on the back, which is really not a machine. It's basically just a sledge that they go back and forth on, and they make a runway. The twin-engine otters can land on anything, but an LC-130 can't. They need more or less a very smooth runway compared to a twin-engine otter. So they'll go back and forth for a couple days and make a 13,000-foot runway by just dragging this thing back and forth, back and forth. Even with that, at the high altitude, if they have to take something very heavy, and it's a heavy load with the friction of the snow, sometimes they have to go a little bit overboard And at that point, they'll use, let me get a cursor here, they'll have to use a jet-assisted takeoff. They use JATOs. And here's a little video. You can see what that looks like. This is an LC-130 taking off in the snow on one of those non-well-groomed runways. And here they light the jets, which are actually rockets, and they take off using the rocket power and the full power of the LC-130 to get off the ice. A lot of black smoke comes out after that one. But when it takes something heavy, really heavy off the snow, that's what it has to do. So it gets very expensive to do things like that. Anyhow, we fly back to McMurdo eventually, get on yet another weird thing. This is called the Delta. They are from 1959. Very uncomfortable. They have basically no suspension. Now we're going out to Ego 5. Ego 5 is at high altitude. Unfortunately, we were stuck at McMurdo for a long time, so we were no longer acclimated to altitude, which is important. At the South Pole, we're acclimated to altitude because we're there for 5 days or a week before we go out to the Egos. At McMurdo, once we lose it, we have to get back to it. So what they did is they took us up to Mount Erebus and put us on a helicopter, flew us up to Mount Erebus. There's our tents. We set up our tents on a volcano at about 10,000 foot altitude and stayed there for 5 days until we were acclimated to altitude. And then they pick us up, take us directly to the airport, and away we fly. This is looking over the edge of that volcano. You can see it's just absolutely gorgeous. The sulfuric fumes coming up. Really nice to look at. I'm not supposed to really go up there, but anyhow, it's really nice to look at. And then we get to Ego 5. We set up our tents because we typically don't stay at those little stations. We typically stay in a tent, set them up outside, get our equipment ready, and get to work. Sometimes you have a little bit of extra time. This one I decided to fly a kite. So I just laid down on the snow and flew the kite for a while. And I had to get back to work. I tied the kite to a shovel. Next morning, the kite was still flying. The winds are pretty steady, so it wasn't my talent that kept that kite in the air. It was just the wind, and it just stayed that way overnight and flew all by itself. Eventually, the plane comes back in to pick us up. We get on a plane and we fly back out. Now we're heading back to McMurdo. You can see that strip behind us here as we're getting into McMurdo. That's where the icebreaker came through. The icebreaker comes through. This is typically towards the very end of the season, the end of January, before things shut down for the winter. They come then because that's when the sea ice is the thinnest. The icebreaker, the United States only has one icebreaker. Sometimes we borrow one from Russia. We're not doing that lately, but we used to. The icebreakers, we only have one of them, but that icebreaker can go at 6 knots, a little over 6 miles an hour, through 6-foot thick ice. Just continuously cruise, and it can break up to 21-foot thick ice by basically riding up on it like that, like a porpoise, and breaking it off. I talk to the people on the icebreaker, and they say once they're going and breaking the ice, even if it's a thin ice, there's no sleeping. It's just so loud and so much vibration, you just can't sleep. Once they do that, though, and have it shipped, this is our little area where they, by Bernardo, where they come in with the equipment. And they come in with a cargo ship. They offload all the new shipping containers. They also take out all the garbage from McMurdo. Then the fuel tanker arrives. That's how they fill up those 17 million gallons of fuel off the fuel tanker, or keep them full off of that. And then the Coast Guard comes back in, ties up next to it. And that's basically the end of our trip. At that point, we get on yet another weird vehicle. This one is made by Caterpillar Tractor, and it is just gigantic. They can all haul equipment, or they can haul people. On the back of it, you can see the trailer for people. Take us out to the plane, and now we have a C-17, which is much nicer to fly than a C-130. They're faster, they're quieter, they don't shake as much. They're a lot newer, and there's a lot more room inside. And a crowded C-17 beats a C-130 every day. And basically, that's the end of it, except if you ever wondered how you get the Southern Lights to turn on, there's the switch. So thank you very much for coming. Really appreciate it. I don't know how our sky is. Do we have anything?
Clouds, as per
Okay.
usual. Unfortunately, that has been our luck. So I want to thank you, Gil, for another great presentation. Thank you all for sticking with us. We are going to be having a question and answer session. And for the people out here, where it's actually light enough kind of with that screen where I can actually see that there's human shapes instead of just shadowy figures in the distance. Although shadowy figures in the distance would be very appropriate for Halloween. That being said, if you have a question, you can raise your hand and just kind of wave it about a bit. Perfect. So we'll start out here.
What time do you use if it's always day in Antarctica?
Well, even day and night we use the same time. We actually use New Zealand's time. Basically, every country that has a station there typically has their own time. And the time they usually use is the last place they fly out of to get to Antarctica. Since we fly out of Christchurch, New Zealand, that's the time we use is Christchurch, New Zealand. Um, it's kind of odd because you're really dealing with three times all the time. Basically, I'm looking at New Jersey time because I have to communicate back here. I'm looking at Antarctic time, and I'm looking at time in Greenwich Mean Time because all the scientific instruments are off of UTC, Greenwich Mean Time. Everything that's scheduled down there is off of Antarctic time, which is Christchurch time, and everything I'm doing back here is off of our time here in New Jersey. So the difference between our time and New Zealand or Antarctica time can vary for the time of year. It's either 15, 16, or 17 hours. I'm sorry, 16, 17, or 18 hours difference. They're 18 hours ahead of us right now. So that can be a little bit different. When dealing back here in Antarctica, excuse me, you have daylight savings time, and you also have, just like you do here. But unfortunately, since the seasons are reversed, they happen at different times of the year, and they don't pick the same days we do, which is why we have that variation between 16, 17, and 18 hours.
Right. Also, in my little travel size cauldron for the people here, you can feel free to take like a couple pieces of candy. I realize a lot of people have been scooting out of here, so do feel free to take those. So, one of our online questions. This is back when we were talking about the polar flip for the magnetic field.
Right.
Since we are technically overdue, is there an estimate for when that might happen?
No, there isn't. It's very poorly understood to begin with. But one thing that has been happening is the North Pole has been wandering. They don't actually wander exactly the same, North and South Pole. The North Magnetic Pole has been wandering quite a bit further and faster than the South Magnetic Pole. But we really don't know from history if that's really a sign that it's happening, the flip is happening soon or not. It happens also over a long enough period that it doesn't affect the animals that navigate by magnetic fields. It goes through many generations of animals before they actually flip. So no, we really don't know exactly what causes it on the Earth, and we don't really know when it's going to happen, or
Um,
if that change right now is part of it.
right. I know there was another hand out here for a question. Oh, it's behind me.
Hi, I wanted to know on a good day, how long do you stay out? Or how long
Well,
can you be outside?
in the summer, I go in the summer, which is our winter. Um, in the summer, you can be out almost all day long. Typically, when I get down there, it's not as cold as it usually gets. It will be about -40, and at the Ego stations, it will be about -30 towards the middle of summer, sometimes -25. At South Pole itself, it actually can get up warm on really odd days. You may actually hit close to 0 degrees, so it's not bad at all. In the winter, it's a different story. In the winter, you can hit 100,
Warm.
110 below zero at times. So then you're not going to be staying out for a long time. One of the people I work with wintered over there. And he said one of the hardest things he had to do is they were pulling a rope to bring equipment up to a higher floor. He said he had to stand out there and hold that rope, and it was 90 degrees below zero. And he said he was never so cold in his life because he wasn't moving, wasn't generating any body heat. He said it was really bad. In the
Uh,
summer, you have all day.
All right. So, our next online question. Uh, and they say, since they think you said we were coming up on maximum, is there a chance we will actually get to see the aurora more south than basically Canada?
Yes, it definitely is. Um, when that KP index I mentioned has to be about 7.5 or more to see it here, typically can happen other times. That's also when at KP5 they start with a scale called G. It's geomagnetic storm. It's just G1 storm, G1 class. When we might have 100 days out of the next solar cycle, the next 11 years, where we'll be able to get with it, but you don't always see them here. And the thing to be careful of, though, is the newspapers and news around here. Anytime there's a geomagnetic storm, they're always running and saying, "See the aurora? It's going to be out there. It's going to be beautiful." Most of the times when you see that, it's not going to happen. They really just jump the gun on it. Take a look at that spaceweather.com and you'll be able to see. By the way, the pictures I showed you at spaceweather.com where it showed the aurora oval and green, green is where it's basically a 10, 20, 30% chance. It'll get to yellow and to red. When it's red, it's a 90% chance. Down here, you'll sometimes see yellow on that. That's when you have a really good chance of seeing it down here. You'll definitely have a chance.
Right. And based on that question, follow-up one was, if you were where you could see the aurora, could you hold a fluorescent light bulb in your hand and have it light up?
No, it's not strong enough for that. It's in typically the upper atmosphere. Well, it is in the upper atmosphere, not down the charge
So no
isn't down
weird
to Earth.
Tesla coil action where you're
No.
you're wandering around. I'm like, I got a light bulb.
No, but it is gorgeous, and it does move. You can see it move in real time. I showed you the pictures I showed earlier, were of it moving basically in time lapse. So in real time, it also is waving and moving like curtains.
Right. Another question out here? All right. So our next online question is, how many UAC&J stickers have made it down there to Antarctica now?
4 that I know of well, 4 that I've done. Let me put it that way. I know all of them. There's some on napkin dispensers down at South Pole Station. There's one on a wall in a dorm, the one that hasn't been torn down in McMurdo, and there are 2 in Agos.
All right. If you guys have any questions, like I said, just hand up and wave them about, because I do have, actually, our online chat was quite curious about things. So the next couple questions, do they still have the VW bugs down in Antarctica? And if they are, have you seen them if they do?
No, I have not seen them. I have seen a couple of really strange vehicles that have traveled to South Pole that have been obviously custom built. One was a Toyota truck that made it there. They don't typically come from, well, they don't come from McMurdo. They come from another area that's closer to the UK station that is driven out there. So one first year out there, that was completely buried in the snow. The transmission broke on it. But no, I haven't seen any bugs.
All right. Are you ever going back to Antarctica?
Boy, I'd love to, but almost assuredly not. A couple things have happened. One is, I mentioned that they tore down one of the dorms and haven't got the new ones built yet, so there's very little room right now to bring people down there. The second thing is, due to financial problems with the government, they've cut over 50% of the projects that are working there. And the third thing is my health. I have a problem with my back. It's got a lot of titanium in it, so probably not going again. But I'd go there in a heartbeat, regardless of anything else that was going on. I love it down there. It is a phenomenal place to be. It is like being on another planet on Earth. It's just really cool.
Right. So on the plane, you pointed out the cut here at the dotted line. Are there also emergency exits, or only the cut along the dotted line with the hatchet?
Well, there's actually an emergency exit on the top of the plane, which basically, if it flipped over, I guess. But talking to one of the crew, they said if they blow that exit, which actually they blow it with explosives, that's the end of the plane. They have to scrap the plane. But as far as that, there's no emergency exits. There's the one door to get in, and if that's blocked by for some reason, the only other way out is with the hatchet.
Fun. All right. So, speaking of the dorms, why did they knock down the dorms for having the new ones built? Were they hoping to use the materials from the old and the new ones?
Gosh, no, the old ones are really wretched. the thing is, it was before COVID, and they thought they could get this done very quickly, and they'd get it done within the one season. And then COVID hit in 2020, and that's basically when they started doing all this. They knocked it down, then COVID hit, and now they're 3 years behind schedule, and it's still not done. And especially now with it's hard to get people in there, it's making it even slower.
Questions? Right. So, how many additional non-U.S. bases are in Antarctica?
You know, I don't really know. There's quite a few. South Korea is one that we're working with right now, building basically one of those AGOs, the Automatic Geophysical Observatories. We're building a portable one to ship down to that. That's the Jangbogo station. UK has them. Christchurch, New Zealand has one that's only about 3.5 miles from McMurdo. Japan has them. Quite a few people have them. I'm not sure of all of them though.
Right. Do they know if the active volcano down there is scheduled to erupt anytime soon?
No, the last time it actually ejected anything was in the late 80s. Like I mentioned, there's a lava pool in the bottom of it, and occasionally it just burps out lava rocks. But the last time that happened was in the 80s, late 80s.
Right. So, next question is, you had decided instead of a tent, you were going to sleep in a hole in the ground. Did they have warnings against setting up camp under the snow versus in a tent?
No, they didn't. But I don't think I kind of did it when they were gone, because I mentioned they drop us off there, and we're we're kind of on our own then, and that's just what I decided to do. So it worked fine for me. It would be a really bad place to be if there was a storm, though, with a lot of drifting snow. But it was a very nice day, so I decided to do it.
Stick a couple flags up top.
Here I was.
At least they'll be able to find the body. Right. So, do they ever military unload the people from the plane?
Never. No, it's dangerous. Actually, we had a crate with our equipment in it once. It's about 10 foot by 10 foot plywood crate, and that actually rolled when it came off. And we were really worried about the equipment, but it survived. But it actually rolled because they're moving along. They're not stopping, and edge digs in and it flipped the box over.
All right. Next question was, why are the maintenance shops so far from South Pole Station?
I don't really know.
You would think you would want to be like, man, this broke and we need it for our heater. I don't want to have to trek half a mile to get to.
Yeah. It's not half a mile. It's probably 150 yards or so. But it's not bad.
I don't know what that is.
About 450 feet, something like that.
How many football fields? How many?
1.5 football fields.
I don't obviously don't follow the sports ball. But yeah, sometimes it's hard to, you spit out a number and I'm like, I can't visualize that. I need something where it's like, yes, scale. Right. So our next question is probably actually regarding Buzz Aldrin. Can you get altitude sickness in space around the moon?
No, probably not, because they keep the space station, they keep the space capsules, spaceships at a standard pressure. Whereas when you're going from sea level up to there, you're not at standard pressure. You're just at the whims of the atmosphere. And going up for South Pole is at 9,301 foot altitude. The pressure altitude there is typically between 10,500 and 12,000 foot, which means basically because the cold air sinks, the pressure there is like you're almost physiologically at a higher altitude than you actually are.
Ooh, someone had made a comment because I had made said, nope, we're still under clouds. And they said, which one of you bought a new scope? And it's actually none of us who are currently here. And I don't know that it's a new scope, but it's a new to them. One of our members bought one of our other members' telescopes. So I fully blame them. Hopefully they're watching. Or maybe they're here. They might have snuck in while I was not looking. Any questions? So we are coming down to the last couple of questions here. So people online, if you want to get those last minute questions in, now is the time to do that. I always like to give them a little heads up because they're on a slight time delay. By the time we're on to our next couple of questions, maybe they'll have heard me. So, the next question, do people ever get stuck in Antarctica, like they signed up to do the summer science trip like you did, but they were prevented from getting out? What happens then?
No, they don't actually get stuck. They do manage to get everybody out in time. That's why that deadline is basically the first week in February to get out of South Pole. And there actually is a week or two after that where you could get people out, come equipment breakdowns with the planes or sickness of the pilots or whatever else. But they do get everybody out at that time. People that are wintering over also tend to get there earlier. They'll get there sometimes even in stay all the way through the summer and then into the winter. Typically, you want people down there quite a bit just to make sure that they fit in well with the South Pole crew and things going on down there. But no, nobody's ever been actually stuck down there. But you do not get out on time. Whenever it's scheduled, it does not happen.
All right. Is freezer burn a problem with the food?
Yeah. A little bit, but not as much as you might think, because being as cold as it is, freezer burn typically happens when things warm up a little bit and cool down a bit, closer to freezing temperatures, closer to zero. It's so cold there that things do not get frost on them inside. There's no humidity, for one thing. Humidity is extremely low. In fact, you end up with cracked fingers from low humidity. And it's not too bad. Things do dry out over time, though, including ourselves.
All right. Any last minute questions from our crowd here? Oh, perfect. Let me just give you the mic.
You talked earlier about predicting, I think, solar flares or solar events, and how is that? What's the mechanism for prediction?
A lot of it is history. Taking a look at conditions that are going on in the sun and seeing how they in the past and seeing how they match up now. Basically, the rate of change of things and the rate of change now. How many solar flares or how many flares happened in the past? How many coronal mass ejections? How many sunspots are coming? And then timing it with that 7 to 14 years, typically 11-year solar cycle. One of the things they're doing, I mentioned that they upped the count for this solar cycle 25.
Your mic just cut out. Let me switch with you.
Okay. Just
Sorry. Sorry.
just 2 days ago, they switched up the prediction for this solar cycle 25. The cycle before that, or the prediction before that, was done way back in 2019. Starting as of this last prediction, they're now going to be updating that on monthly using a new experimental method, of which I know nothing of. I can't tell you, but apparently they have a way now to do it much more frequently.
All right. So I want to thank that was all the questions here. All right, and that looks like that wraps up the questions online as well. So I want to thank you, Gil, for another great presentation. I want to thank everyone who's joined us here and online. If you're online, don't forget to hit those like and follow buttons. Let us know we're doing a good job. And with that, our next presentation, we'll see you online only first Saturday in November.
And
Have
thank
a
you
good
very
night,
much.
everyone.
Thank you very much for coming and for coming online also. Sorry I had a rough start at the beginning there. Bye.
Also, don't forget to take some candy.